Hello and welcome to today's video. So on the workbench today we have an Evnetics Soliton Jr. This one is the serial numbers over here, and I've figured out how to actually read these now. So this was made March 2013, and it's serial number 5011. It's upside down. So, yeah, a customer was having a saturation error, same as the last, the Soliton 1 that was fixed a couple weeks ago. And, yeah, kind of expected there to be only one of those IGBT bricks in there, same as, but no, they use a completely different one. It's got those, these spring contacts that go to the gate driver board over there, so it's a different gate driver. But yeah, it's definitely shorted. Conveniently, they got the schematic on the side here, so the IGBT is between, let's do this. So the IGBT is between pins 2 and 3, and then there's a catch diode between pins 4 and 1, well, and 3 and 4 connected together. And then if you look down here, 8, 12, and 15 are all connected together for the gate. And yeah, so this is the part number here for it. So it's interesting that they use a different module, but let me show you. This is definitely shorted. So we expect pins 3 and 4 to be, connected together because that's what it shows on the side, and they are. But we would not expect like 3 and 2 that's the IGBT, and it's definitely shorted. And of course, 2 and 4 shorted. And out to the diode, that works. So if I flip this around, the diode is still intact, but yeah, the IGBT is definitely shorted. Not only that, but the gate. So remember how we said, what was it, 8, 12, and 16 are all connected together. So if we get on, it's going to be really hard to do here, but I can do it, maybe. Tripod. Probably should have done the tripod. But if we look between here, as the schematic on the side says, those should be shorted. But so should this, and it's open to that guy. And then if we do a gate source, we've got a short across there. And then, of course, 11 and 12 here for the gate source are also going to be shorted. But out to 16 isn't. So my guess is that with this package, you can see how they've got all these extra holes that aren't populated. There's probably supposed to be, my guess would be they've got a different version that's in this package. It's IGBT, 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 and IGBT to make a three-phase bridge. But this one looks like it's got these 3 IGBTs in parallel with body diode, or the diode somewhere. And my guess is that this is the one that died. And when it died open, so because its gate no longer is connected. So my guess is this guy died open. And then when that happened, we had a short. And then these two guys just shorted to essentially ground, which I think is okay, because if we go over and look at the gate driver, remember the last one, our gate driver blew up because it got exposed to the high voltage and it popped the diode. So that same diode is right there, the Zener that was protecting the output. But if you look, our gate drive is fine. Like, there's nothing wrong with it. So I think that our gate driver chip and our essentially our spike suppression diode is fine. So I think that our gate driver board survived this, which is good. So I think all we need is a new one of these IGBTs, and that should get it back up and running. And I'll see if the customer wants to let me keep it, like if he doesn't want the damaged one, because you can kind of see in these holes. I don't know if you can get it right. You can see all the IGBT in there. See the little wires down in there? So if I come over here, you can see the other one over there. So those would be the actual IGBTs. are underneath here. And that's why I think that this is just a subsection of a package where they would have 3 on this side and then 3 on the other side. But yeah, you can kind of see the IGBT chips in there. It'd be interesting to open it up and see if we can't see it completely, you know, shorted out or destroyed by just, like, you know, cutting off the package. So that'd be something interesting to play with. And then, yeah, the other thing is, you know, you see how tiny those little tiny welded traces are on there, and all the current flows through there, and then, you know, you have these giant copper bus bars. And it's like, well, the connection on the IGBT is only that big, and then internally it's just those little tiny wires. But, you know, and again, these guys are just kind of siliconed in. They're not bolted down, the capacitors. And for those that want to know, I think on the side I read off of one of them, they are 150, you can kind of see it there in the corner, 150 microfarad 600 volt capacitors. And then we've got the contactor back there, and there's a few other little pieces. The current sensor goes on there, but I'll have to glue that back in. And yeah, other than that, the same processor board with the WISNet on it. And the only thing that's different is the gate driver, the IGBT module, and the capacitors. But anyways, yeah, that's it. Hopefully we can source one of these IGBTs and swap it out, and hopefully it fixes it. So yeah, anyways, thanks for watching. Bye.